Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way.
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi everyone, welcome back to Geeks for Geeks practice and welcome back to another problem of the day analysis. Quickly give me a +1 in the chat if my voice is clearly audible to everyone so that we can start with the live stream. Hi Vanshika. So all of you can just quickly give me a +1 in the chat and then we'll start off with the problem as well. Okay. So that I can know that everything is working fine. And then I'll add my screen as well. Okay. Hi Rohit Kumar. All right. Hi, Shriyansh. Okay. Hi, Rishit. Hi, Rishit. Your optimization was good in the last stream. Okay. So I'm adding my stream as well. Like I am adding my screen. So just quickly give me a +1 if everyone is clearly able to see my screen. And then we'll start off with the problem as well. Okay. All right. So you can hit the like button and then we can start off with the problem as well. Okay. Before that, let me change the format as well. Yeah, this is better. So let's just start off with this problem, right? So what does the problem say first of all? So the problem is nothing but Floyd Warshall. So what is Floyd Warshall? Like how many of you know about this algorithm that is known as Dijkstra algorithm, right? Do you know about Dijkstra algorithm? Yes or no? You guys know about Dijkstra algorithm? Definitely yes. Right. Now what is Dijkstra algorithm? Dijkstra algorithm is nothing but single source shortest path, right? It is nothing but single source shortest path, right? Correct? You can give me a +1. Like if I give you a particular source node, let's say I give you a particular source node, okay, and I name it as let's say that source node is 1. Okay, then if I use the Dijkstra algorithm, so it will help me to find the shortest path from the source node 1 to every other node. Correct? You can give me a +1 in the chat. Correct? If I give you a source node as 1, so Dijkstra algorithm will help me to find the single source shortest path. That is, it will help me to find the shortest path from starting from 1 to all the other nodes. Correct? You can write a +1 for this. Correct? That is what the Dijkstra algorithm does. Okay. Now, what is Floyd Warshall algorithm? The thing is, what is Floyd Warshall algorithm? So, in this particular Floyd Warshall algorithm, what happens is it is nothing but multiple source shortest path, you can say, right? In this, what we do is it is nothing but multi-source multi-source, right? Now what do we mean by multi-source? By multi-source, you can understand that I'm using someone else's laptop and you can guess whose laptop I'm using. So that is why I do not have my writing pad, my editor, like my you can say OneNote. So this software is a little bit new for me. So basically you can understand this thing, multi-source, right? Multi-source. When I talk about multi-source, so what do I mean by that? So I am in that case, I am saying that if suppose there is if there is a vertex 1, you can say if there is a node 1, then from 1, I will find the shortest path from 1 to all the other nodes. Okay. Right. That is what I need to do. For let's say there is node 2 also. So for 2 also, for all the other nodes, I need to find the shortest path. Okay. For 3 also, suppose there is 3 also. So for 3 also, from 3 to 1, 3 to 2, 3 to 3, like 3 to 4, whatever, for all the nodes I want to find the shortest path. This is what we are expected to do in this question. Okay, like all pair shortest path, you can say all pair, like for all possible pairs you want to find the shortest path. Please write all in the chat, or you can write a +1 in the chat as well. Is that clear to everyone? What is the expectation from the problem? What problems does the Floyd algorithm solve? So the Floyd Warshall algorithm helps us to do what? It helps us to find the shortest path from every node to every other node, kind of thing. Correct? Sir, please put the link of the problem in the chat. Okay, so I will do that. Right. So let me put this link in the chat. Okay. I need to use this thing, right? Command C. Okay. Now let's put it inside the chat. All of you can give me a plus one if you have understood till now. Okay. It is not like currently I cannot. But by the end of this, I can. I think it is also present in the chat. You can solve this POD. I think in the chat also. It is like in the description of this video. Okay. Great. So via every node, all the other distance, right? This is what problem is solved by multi-source Dijkstra. Now, going further, if you will talk about other things, so how can we do that, right? So we have to think in some manner. So let's say this is a particular node. Let's say this node is one. Okay, let's say this particular node is one. Then let's say one is connected to something like two. Okay, then let's say two is connected to three. Okay, let's say three is connected to four. Okay, let's say four is connected to five. Something like this is there. Okay, something like this. Okay, and let's say this path is also there. Let's say the cost of this path is, let's say, 10. Let's say this path is 1 1 1 1, something like this, and there are a lot of other edges that I'm not drawing. Okay, so in this case, what kind of process we try to do? So see, what we can do is, like, we can say that if suppose this is the node 5, so we can say one thing, that if we have a particular node, right, we have one, right, and we want to find the shortest path from 1 to 5. Okay, we want to find the shortest path from 1 to 5. So there can be many ways to do it, right? So like one thing that we can do is, from 1 to 5 we can find the length. Okay, if we want to reach from 1 to 5, maybe we can directly reach it if it is if there is a path like that. Or maybe what we can do is, we can start, like, we can, let's say, we can go from 1 to 3 via this path. Okay, and then after that, what we can do is, we can go to 3 to 5. From 3 to 5, you can say, right? Or maybe another thing that I could have done is, let's say there was 6, and then I could go like this. So from 1 to 6, I can go to 1 to 6, right? And then I can go from 6 to 5. Is that clear? Is this part clear? All of you can hit the like button and give me a plus one. Is this clear? There can be many ways the in which I can find this length, right? Suppose this particular length is coming out to be 10. Okay, now reaching from 1 to 3 will take, like, from 1 to 3, this path will take some cost, and then 4 to 5 will also take some cost, correct? So I'm going to this particular node, like, let's say if I have to calculate 1 to 5 distance, so I'm going from 1 to 1, 1 to 5, I can go via multiple paths, like I can go with multiple paths. Is this part clear to everyone? All of you can hit the like button and give me a plus one if you are clear with this, right? Yes or no? Basically what I'm saying here is, I am saying that if you have, let's say, A and you have B, so there can be multiple paths now. Like, you can say that maybe I can go through this path, right? This will have some cost, or I can directly go through it. Let's say this path, this is having a cost of 10, this is having 5 and 7. Like, let's say this is having 5, this is having 1. So if you go to from A to C, and then you go from C to B. Okay, so ultimately if you want to reach B, so in that case, you will take the cost length, like the cost will be 6, or maybe you can go to A to B directly. That cost will be nothing but 10. There can be various other paths also, right? Rishit is also clear, right? Maybe there can be a path, let's say D, okay, then E, okay, and then let's say this particular path. So what I'm saying is, maybe another path I could have taken is from A to E, right? Basically, suppose that A to E, in which D will also be covered, then from E to B, okay, and maybe this might be the minimum. So I am saying that what we will try to do is, what we will basically try to do is, we suppose that we want to reach from a particular node I, right, to J in the shortest distance. Okay, if we want to reach from I to J in the shortest distance, so in that case, what we can do is, we can either directly go from I to J. Okay, that is one thing that we can do. Or another thing that we could do is, like, we can simply say that if we are at I and we want to go to J, then we can go through a particular middle path. Are you getting this? We can go through some particular middle node, let's say K, right? Through some node, right? You can say that we can first of all cover from A to E, right, and then E to B. Are you getting this point, guys? Yes or no? Is everyone clear with this particular part? Okay. Right. So we can do what? We can go via multiple paths. Now, when I say that we can go via multiple paths, So basically, now what does this indicate? So this indicates that if I want to go from I to J, right? If I want to go from I to J, then what I can do is I can like I to J. So I can do what? I can first of all go from I to K, like some particular path, which will be optimal. And then I can go from K to J. Okay, this is one thing that I can do. Is this part clear? That what I can do is I can go from I to K, like maybe some there's a particular path from I to K that is short, and then from K to J I can go, right? And there can be various, like all the possible paths that are there, right? All possible paths. Like if I want the minimum, right? If I want the minimum path, so what I'll do is I'll explore. Okay, I'll explore all the paths, right? All the paths from I to J, right? All the paths from I to J, right? Are you getting this point? Like if, like first of all, if I is something and J is something, let's say I value is, let's I node is one, let's say, and J is, let's say, four, right? So I'll explore that. Okay, from like from one, let's say I go to zero, then from zero I go to four somehow, right? Then I'm saying that maybe what I could do is from one I go to, let's say, two, and then from 2 I go to 4. Okay, and in this these paths can also have certain length. Is that clear? You can write clear in the chat or +1 in the chat. Like this is what I'm saying. Like they can be a certain like they can be a node K, such that first of all what you can do is from I to K you can go, and then from K to J you can go. This is how you can distribute this particular problem. Now in this particular case, what will happen here is, if you will look further, if you will look further, so in this particular case you can simply say one thing. Now what can you say? You can simply say one thing. We can see that likes are less and people watching are more, so you can hit the like button if you haven't already. Okay, now in this particular case what can happen? So basically, if you will try to understand this particular thing here, that if you are going like if you are going from I to J, right? So you can go via path K, right? So from I to K you can go, then from K to J you can go, right? This is one thing that you can do. If you are going from let's say I to K and then from K to J, right? So I am saying that distance, like first of all you'll cover, like there will be certain K, suppose, so I to K plus distance of K to J. Okay, this is what you can do. And let's say you have certain distance, right? So basically you will try to explore all such paths and you will try to find the minimum. Please write +1 in the chat. For all such kind of paths you will try to find the minimum. Now is everyone clear with this particular thing, that if you are going from I to K and then K to J, so you'll explore all such paths and you'll try to find the minimum distance, right? You'll take the minimum out of them. Is that clear to everyone? Is that clear? So you'll explore. Correct, correct, definitely. Now, here one more thing is there, right? One more thing is there. Let's say you will say that, okay, sir, what we will try to do. So from 1 to 2, let's say we have path like this, okay, and let's say we want to reach this. So you will say that, let's say that I'm saying that this is I, right? Let's say from 1 to 3 you calculate the path, and then from K to J you can say, right? So from 1 to 3 you find the length, and then from 3 through 4 you find the length, right? So you will say that, like, can I say that this particular path is given, like this particular cost is given, 3 to 4 cost is given, please give me a +1. This must be given, that this particular path from 3 to 4, it is direct path na, from one node to another, so this will be given to you, right? Suppose, right? But you will say that, sir, how will we calculate the path from 1 to 2 or 1 to 3? The optimal path from 1 to 3, maybe this particular path can be there, or maybe there can be some other nodes through which we can pass and then we can reach 3, right? So there can be various ways now for this path. For this, there are two segments, 3 to 4 and 1 to 3. So 1 to 3 is there, 1 to 3 is there. Can I say that 1 to 3 is not direct? 1 to 3 is not direct. You can give me a +1 if you are clear with this. And if 1 to, like the path from 1 to K, that is 1 to 3, it is not direct path. So we do not have a direct value for it. So can I say that it should already be calculated? It should already be pre-computed? Yes or no? Are you getting this point, everyone? Is everyone getting this particular point, that it should already be calculated? Is everyone getting this? It should be pre-calculated. Is everyone getting this particular point? Okay, yeah. So in this particular case now, what you will say is that if you have this particular path, I'm explaining it in the next page. So if you have 1 to 2, then you have 3, like let's say you have 4, like suppose. So in this case, if you have the path, like let's say there are various other paths, right? I'm not considering them. Let's say there are several other nodes and other paths that are also there, right? Suppose there are higher length paths and all. So in this particular case, what you need to understand here is that, like if I am calculating the distance of 1 to 3, right, plus the distance of 3 to 4, okay, So I can say that this distance of 1 to 4, 1 to 3 must be already calculated. Like distance of 1 to 3 must be all should already be minimum, right? It should already be optimal. It should already be optimal, right? It should already be optimal. And when I say that it should already be optimal, right? So it should be already calculated, right? It should be already calculated. And that is when you can say that you will calculate what? In that case, you can say that you'll calculate the smaller result first, right? Smaller result first, right? Okay. Now, when you calculate the smaller result first, so basically you can say that you will calculate the smaller sub problems first. So you can say that indirectly this is nothing but DP approach. Okay. Is that clear? This is nothing but DP kind of approach, but it is a brute force approach only. It is a brute force approach only. But the main thing is that we are applying the concept of DP here. Is everyone clear with this? Why we are applying the concept of DP? Because like a particular sub problem should be calculated. Like if I want to calculate 1 to 4, suppose, and that is nothing but 1 to 3 plus DP of 3 to 4. Okay, so in that case, I basically need to do what? This should be already calculated, and this is nothing but a DP approach. Is that clear to everyone? Okay, everyone is clear with this? This is the basic concept of this particular problem. Okay, right. So what should I do? See, in that particular case, I should say that I should run a loop. Like, what should I do? So I should say that, okay, for I starts from 0, because I want to calculate. Please write ij in the chat. Ij in the chat. I want to calculate what? I want to calculate every optimal path from I to j, right? So d distance of ij should be always storing the minimum, correct? The minimum distance from I to j. That is the multi-source shortest path, Floyd Warshall algorithm. So I'll say that I starts from 0, I is lesser than n, and then I'll do an I plus plus. Okay, like you can say the number of vertices basically, and then I am saying that, okay, for j starts from 0, right? Let's say j is lesser than n kind of thing, lesser than the number of vertices basically, and then I'll do a j plus plus, right? So what I'll do now is, like, I can simply say this is the rough idea, the pseudo code for it. Like this is the pseudo code, right? So I'm saying that what I'll do is I'll say that, okay, dp of ij is equal to nothing but like what? Minimum of like every time, no? Minimum of the distance that I might have calculated up till now, comma d of ik. Let's say there is a certain k, okay, plus d of kj, right? This particular thing. Is everyone clear with this particular part? Very basic, to be honest. Is everyone clear with this part? That there should be some intermediate k, no? There should be some intermediate node k here. You can see here. Like I'm highlighting it again with another color. You can see this particular thing. This particular thing. There should be some certain k, right? Is everyone clear with this? So that is why what I'll do is I need to check for all possible case, na? All possible case. So what I'll do is I'll write a for loop kind of this thing. Like, is that clear? I'll write a outer for loop for this, for dealing with this particular kind of situation. What I will try to do is I'll try to write a for loop. So for every node, na, for k starts from 0, k is lesser than v, or you can say n, and then I will do a k plus plus. So I'll do it for all the possible case, for every I and j. I will try to do it for all possible case. In that case only I'll be able to minimize. Is this concept clear to everyone? Okay. Is this concept clear to everyone? That if we are saying, right, if we are saying, first of all, the thing is that if we are saying that, okay, dp of ij, like we'll try to, in that case we'll try to explore what? Every I to k path, okay, plus the k to j path, right? That is what we are saying. In this case, suppose that this is not direct, suppose that this is not direct, so in that case it should be optimally calculated, right? Optimally calculated. It should be optimally already calculated. So that is nothing but kind of dp approach, that the smaller sub problem should be already calculated, right? So in that case you are saying that dp of ik must have been already calculated. Okay, then only you will try to optimize it further, na? Then only you can say that, okay, this is the minimum, and now I need to minimize the dp of ij, like the distance of I to j. Is that clear? Chaman is clear with it. Okay, what about Rishit and what about other people? Most of you must be pretty much clear with the intuition of it. All right, great. Right. So this is what we are doing. Now, what is the time complexity of the approach? Anyone can tell me? Anyone can tell me? What is the time complexity of this approach? If you will see, I need to check for all possible i's and j's, right? Because of 3 loops from order of, yeah, you can simply say that because we are running 3 loops. So this loop is order of n time, right? And this loop, inner loop, is also order of n time. Now this is another outer loop, order of n time. So overall, there are 3 loops running one inside other. This is the first outer loop, then the second loop, and then the third loop. Okay, so overall there are three loops running. Okay, so that is why we need to say that the time complexity of our thought process would be nothing but order of n cube, right? This is the approach for this particular problem. Okay, now one more thing that we have been given, like do you know about this particular thing, adjacency matrix, right? You know that a graph can be represented in terms of adjacency matrix also. Yes, definitely. So in that case, this problem basically says that you will be given this kind of matrix. Okay, you'll be given this n cross n kind of matrix here. Okay, you'll be given, yeah, basically Joel, you are saying the correct thing, but overall it is going like every loop is running n times now, so that is why the complexity expected will be nothing but order of n cube only now. Okay, Joel, is that clear to you, Joel? I hope that is clear, right? So it says that the problem is to find the shortest path between every pair of vertices. Okay, so basically they are saying that suppose that we have a particular grid. Okay, we have a particular matrix like this. Suppose I'm drawing it like this here. I'm not using my board, so that is why it is a little bit uncomfortable. So please bear with that. Okay. Now this is 1, 2, right? Now if you will see here, so what if I have this path as 0, suppose this is 0, this is 0. Okay. If let's say if I talk about the 0 to 3, right? If there is a path, direct path from 0 to 2, na, in terms of graph, so that is let's say it is its value is 3. But if suppose there is no direct path from 0 to 1, na, then they will mark it as -1. Is that clear? They will mark a particular path as -1. Okay, if 0 to 1 path is not existing directly, then it will be marked as -1. Okay, is that clear? Is that clear? Is that clear to everyone? That if there is no direct path from, let's say, I to j kind of thing. Okay, so in that case it will be marked as -1. It will be marked as -1, right? So in that case you will not use it. No, you will not use it, right? Because it is not possible now. Like you need to understand this thing, right? If you are saying that, okay, I'll go from 1 to 3, right? Suppose, right? And then you will go to like 3 to 1, 3 to 4, right? So overall you are saying that you will go from 1 to 3 and then you will go to 4, right? Suppose. So in that case, if this path is not possible now, so you'll not consider such kind of paths. You don't need to put them, like you don't need to put them as mine, this thing you can directly check, Chaman, you can directly check them by using the if condition, if condition. You can directly use the if condition in this particular case and you can do that. You don't need to put them as infinity or intermax. All right, now let's understand what we will be doing here. So I'll just show you my submission that I have done. Just a second. Okay, so let me open the GFG IDE. All right, now let's have a look at the solution as well. Okay, so let's put my solution here. Okay, let's put the C++ here. Okay, fine. So see what I have done here. All right, so let's have a look like what I have done actually. So if you will see here, what I've done is I will first of all what I'll do first of all is that first of all, let me remove some of the comments here. So what we have done here is we have first of all calculated the number of nodes, that is you can say v, or like number of vertices that we have, that is v, or you can say nodes as n. Okay, then we are running a loop from k start from 0 till k is lesser than the number of nodes, and then I'm doing k plus plus. I'm running another loop I starting from 0 till the end. Okay, and j, like 3 loops as I've said, right? If it happens, great to see you, sir. Thanks a lot, Gaurav. Right. So if from I to k, okay, if understand this thing, guys. If the matrix is given, right? If the matrix is given, and if the matrix of I to k, okay, is equal to -1. Let's suppose that I want to go from what? Let's say I want to go from okay, let me use a new page. Let's say going from, I want matrix of ij, right? Basically I want to go from I to j, right? So let's say if I'm going with the help of a path k, so I'm saying that if I'm going from, like, that will be nothing but ik plus kj, right? But suppose this particular value, okay, suppose that this particular value is -1 now, so it is not possible. Please write not in the chat. It is not possible for me to do it, right? If ik is equal to -1, it is not possible. Or if kj is equal to -1, then also it is not possible for me, right? It is not possible for me. Right? Are you getting this point, guys? Is everyone clear with this particular part? Okay, just give me a second. Okay, everyone is clear with this? All right. Uh, okay. Right, everyone is clear with this thing? All right. Now, if it is not possible, then I'll continue. Now you can write C in the chat. I'll continue. If ik is equal to minus one, kj is equal to minus one, then I'll simply continue. Right, I'll simply continue from there because I'll ignore it. Right, I'll ignore it. Like I cannot go through that particular path. That is not possible now. So you can write C in the chat as an acknowledgement that if I cannot go through that part, then I'll simply continue from there. Right. Otherwise, you can hit the like button, guys. I can see still a lot of people are watching. Okay, great. Otherwise, if it is possible, now if from I to k and k to j, right, there's a path possible. So I'll calculate the current distance, right? I'll calculate the current distance, and if the distance from ij, right, if the distance from ij, right, if it's equal to minus one, if it's equal to minus one, right, if the you can say if the distance of ij, if it's equal to minus one, right, so that means there's no current path that is stored, right, there's no path, right, if it is minus one, there's no path, there's no path. If we have nothing in our life, right, if we have nothing, that means we have nothing, right, you can write n in the chat. There's that, this means that if matrix of ij, or you can say d of ij, right, or you can say mat of ij, if it is what, if it is equal to minus one, right, so that means there's no path. If there's no path, right, so in that case you can say that, okay, if I'm getting a path via k, right, if this happens, right, if from I to j there is no path, but if you are getting a path from I to k and then k to j, so whatever cost it is having, at least you are getting a path, right, at least you are getting a path, so you'll store it. Now please write store in the chat. If there's no path from I to j, so that means the distance is stored as minus one, right, but if from I to k and k to j there is a certain path, then you will simply do what, guys, you will simply do what, you will simply store it. Correct, that is what you will try to do, right? Okay, that is what you will try to do. Otherwise if there is some, if there is a particular path, right, understand this thing, that if there is a particular path, in that case what you will do is, if you have options now, if you have several paths, right, if you have like if you have like options, you can say options. I'm not good with using math. Okay, if there is if there are some options now, then you will do what, you will choose the best path, right, you will choose the best path, or you can say you will choose the minimum path, right? Is that clear? Is that clear to everyone? Is that clear to everyone? Is that clear? I hope that this is pretty much clear to everyone. That is how you can deal with these things. Like if there's no path, like if from I to k and k to j there is no path, then you'll simply continue, right? Otherwise, what you will do is you'll calculate the current distance. If from I to j there is no path, then you don't have any option. As of now, you'll store this path because this, at least you are having a path, because you need to store the minimum. But if you don't have any path up till now, then you'll store it. Otherwise, if you have several options, then you'll store the minimum out of that, you'll store the best option. Is that clear to everyone? And the complexity will be order of n cube kind of thing, and this is nothing but a DP approach. So all of you can do one thing, you can hit the like button and give me a +1 if you are clear with this overall. Is everyone clear with the thought process of this algorithm overall? Right, this is how it's working. Okay, this is nothing but the Floyd Warshall algorithm. You can say it is used for multi-source shortest path, right? Floyd Warshall. And the complexity is nothing but order of n cube. This is about the time complexity. The space complexity is nothing but order of 1, right? Constant space, because we are not taking any extra space. Okay, some path is better than no path, absolutely. Okay, so everyone is clear with this? Just quickly give me a +1, guys. Is everyone clear with this overall? Okay, just hit the like button. Okay, is the order of n cube important? Like we run the loops from I to k. Yeah, basically from I to j you want to find the path, and you want to run for all possible like all possible intermediate path, all possible intermediate, like you can say You want to run for what? All possible intermediate stations, right? Stations. So if you want to run for all possible intermediate stations, in that case you need to run a loop for that as well. Sir, I'm in second semester, just started Java. So are these SD sheet going good for me? Yes. If you will be like, I think you can understand one thing, that Abhinav, Suniti, like you can understand one thing, that currently these days, Abhinav is there, then Suniti is there, right? Gaurav is there. So these people are doing the GFG SD sheet, right? So what you can do is you can watch their videos as well. That will help you a lot, right? Okay. Other than this, we have also done the 6 hours and the 4 hours long live streams on GFG SD sheet. So you can also watch that. That will help you to implement better, and that will help you to develop better logic. Okay. And you are very consistent, Joel. So I'll say that you have like guys like you. I can see Rishit is also there, then Chaman is also there, so I can see Gaurav is also there, right? So Yogesh is also there, so a lot of people, Rohit is also there. So I can say one thing, that you guys are quite consistent. So if you will do these things, if you will do, like, it's completely for free now, so you can do one thing. You can, after even the recording is over, if you cannot watch it live, you can watch the videos at 2x if you want, right? So that will help you to understand the things better. All right. Okay, so this was it from my side, everyone. So quickly give me a +1 if you have understood the problem overall. And after this video is over, okay, after this video is over, you can do one thing. After the live stream is over, you can do one thing. You can comment down understood in the chat as well. Okay, understood in the chat as well. After this video is over, will you do it? You can give me a +1 if you will do it. Okay, and then I'll end this stream as well. All right. So everyone can give me a +1 if you will do this. If you should write understood after the video is over as well. Okay, thanks, Yashit. This is saying, I'm mad with coding. If you just ask to code, I'll do it. Yes, great. Like that is what that this is what is needed, right? This is the need of the hour, right? If you consistency is the key. Consistency is the key. If you will do consistently, then you will like I'll say that like package is directly proportional to the number of hours, right? You can say that package that you will get is directly, it is like that is directly proportional to the amount of coding that you are doing, right? Okay, great. So this was it from my side for today. Okay, yes, layoffs are currently happening, but I cannot comment much on those things. Like this, like after 6 months or 1 year, things will always be fine. Okay. Okay, so please make sure to comment down understood if you have understood this video as well. And thanks a lot everyone for joining. We will meet in another live session for problem of the day. Till then, take care, goodbye, and happy coding everyone. Okay, bye everyone, and we'll see with I'll see you with another problem. Next two problems for this week are also very interesting, so let's meet then. Okay, bye everyone, take care, thanks a lot.